Creating a music visualizer with an LED matrix, Arduino Uno, and Raspberry Pi from an audio input file. I'm creating a visualizer that's synced to the beat of music. There are several different ways to visualize music, but most visualizations, including mine, deal with analyzing changes in audio frequencies. Let's quickly review some concepts about frequency. Frequency refers to the number of cycles a wave passes per second. These cycles are measured in hertz, and changes to the frequency can be considered as changes in wavelength or the period of that wave. The sensation of frequency is experienced as pitch and volume. The larger the wavelength, the lower the pitch. The shorter the wavelength, the higher the pitch. Volume is expressed as changes in the amplitude of the wave. We'll also consider a beat to be the change from an instance of low amplitude to an instance of high amplitude. In this project, I'm mapping the amplitudes or volume of the sound wave to different states on the LED matrix. This is a graph of a sound wave that you typically see from a music audio file. It's important to note that when an audio file is created, all the different instrument sound layers are merged into one sound wave, like the one you see. So because of this, when we perform a frequency analysis, we'll be unable to do a real good job of separating the different pitches. So instead, I'll be analyzing the changes in amplitude to sync the lights, and you can easily see the changes in the graph. So to do this, let's look at some of the hardware we're going to be using. We're going to have a Raspberry Pi Model B, and we're going to need an A to B USB cable because we're connecting the Raspberry Pi to the Arduino. And the Arduino is going to be used to power the LED matrix, and that's going to be connected via a 16-pin ribbon cable and 4-pin power cable, which are included with the matrix. We're also going to need just a simple auxiliary cable and some sort of speakers. Those are just the ones I own. In terms of the different software we're going to be using, we're going to have the Raspbian OS, Arduino IDE, and Idle IDE. To complete this project, I'll be building from the top down. My first step is to connect the Arduino to the LED matrix. The LEDs are a SparkFun product, so it already has a hardware hookup documentation and also an Arduino library which I'll use to control the LEDs. At this stage, my primary goal is to establish control of the LED matrix and create a general map for the data inputs I'll be using. I have a hardware hookup deadline for March 1st and a software deadline of March 15th. The next step is to connect the Arduino to the Raspberry Pi. To do this, we need to establish a serial USB connection from the Raspberry Pi to the Arduino. This serial connection enables us to send data one bit at a time. We'll be using the Pi serial library to read from and write to the serial port with Python. We'll also need to develop a bit of code to be able to handle this process of communication. I have a deadline set of March 22nd, 1 week after the previous deadline. The next step in this process is performing the frequency analysis on the audio input. We're going to be using the YAF Python library, which is an audio features extraction tool. We're going to be taking the audio input and performing a frequency analysis, and that will give us a graph similar to the one we saw before of the frequency spectrum of the audio file. Then I'm going to write the dynamic beat detection algorithm, and this is going to be essentially just looking for large changes in volume of the audio file. And then after we have those beat detected, we're going to map the different beats to the LED states. So after the build is complete, the next thing to do is put it all together. you'll notice, and you could probably gather as I was going through, that the build is completed in a different order than the actual process will execute. So the way it's going to happen is the first we're going to have an audio input file, and there's going to be a frequency analysis performed on it using the YAF Python library. Next thing is to map the frequencies to different values on the LED matrix. This is where the dynamic beat mapping algorithm is going to be useful. And the last thing to do is make sure that the song is played through the Raspberry Pi output into the speakers at the same time that the lights begin to move. And that concludes the details of my build.